Now, question number 14, it's the first question about thermal physics, the second block in the IGCSE Cambridge syllabus here. For the year May-June 2020, okay? A gas is heated in sealed container, heated. The volume of the container does not change. What happened to the molecules of the gas? Now, the molecules of this gas, what happened to them? Yes, Abdurrahman, thank you. Does the average distance between them increases? No, this is the volume remains constant. Does the average kinetic energy of the molecules increases? Yes, they are heated, so they have higher temperature. The mass of each molecule increase, the mass doesn't change, okay? The volume of each molecule increase? No, it's also not correct. Yes, thank you, Saif, Marwan, Muhammad, and Abdurrahman. So the answer is B, all of you are correct. Question 15. Water, okay, in beaker evaporates when it left on a bench for a period of time. Which three factors, okay, all affect the rate of evaporation? Okay, the wind speed, yes. Surface area, yes. Temperature, yes. The wind speed, yes. Temperature, yes. Volume, no. Volume, no. And the last one, also volume. So the volume, how much the container itself, it doesn't matter how much the surface area of it. Yes, it does. Okay, so the factors is the wind speed and the temperature and the earth's surface. So the answer is A. Thank you, Marwan. Thank you, Muhammad. Thank you, all of you. So the answer is what is A. Let's move on to question 16. Question 16, a solid is heated, causing it to expand. What effect does this have on the mass and on its density? Now we know that the mass doesn't change, remains what? Constant, remains constant. But what happened to the density? We know that density equal mass, which is constant, divided by what? The volume. And they said that the volume expands. So as the volume expands, becomes greater, what happened to the density? Yes, the density what? Decreases. So the correct answer is what? C. Thank you, Sarah. Thank you, Saif and Noah. Correct answer. Good. Question 17, sorry. The diagram shows 4 blocks, okay, of steel. The blocks are all drawn with the same what? Scale, okay? The same quantity of thermal energy is given to each block. Which block shows the greatest raise in temperature? Which one has the greatest raise in temperature? Now, the greatest raise in temperature, we know that according to the formula, energy equal MC delta T. They said that we are talking about steel, so we are talking about same specific heat capacity. And they said that same amount of energy is given, same quantity of energy is given. So to make the change in temperature the highest value, okay, the greatest rise in temperature, that's supposed to make the mass the smallest value. And to get the smallest mass, we have to get the smallest what? Volume. So the answer is what? Is A, the smallest piece of what? Steel, okay, has the smallest mass. So that means the rise of its temperature, it will be the greatest, okay? So the answer for 17 is A. Clear? Okay. Next. 18. Why some materials better thermal conductors than others? Now we know that conductors, they are good conductors because they have a lot of free electrons. Okay, they can transfer the energy from one molecule to the next one, okay, as it passes through. That's the first reason. Second reason, the molecules, okay, of conductors, they are close. So as they vibrate, they collide to the neighbor molecules until it's transfer the energy from one molecule to the other. Okay, so A, metal contains free electrons which help to transfer energy. This is correct. Okay, metals, okay, sorry, molecules in metals are in fixed positions. Okay, so what is this? Make it good conductor? No. Molecules in metals can move freely. That's not correct. Okay, molecules in metals vibrate faster than those on other. No, it depends on what? On the temperature. This depends on the temperature and doesn't depend because of the different material. So Okay, there's other factors, but this is not correct always. So the answer is what is A in this situation. Good. Any question here? Thank you, Muhammad, Sarah. Okay, let's move on to question 19. What do we have in question 19? Two freezers, X and Y, okay, are identical, except that one has a door open on front, okay, at the front, and the other has a door open from the top. So when you go to a mall or supermarket and you want to buy something, for example, an ice cream, because it's summer now, okay, and you want to bring what, to open the door here to bring what, any piece of food or ice cream that you wanted, okay, you will feel that cold air falls like this, right? But most of the malls, okay, they have these types of what, of freezers that for ice creams. So when a small kid open it and leave it without closing it, the air is still trapped in it and do not fall that easily. Okay, but what they ask here, both doors are at the same size and they are opened, okay, for the same amount of time. Okay, which freezer gained the least amount of thermal energy? Which freezer gains the least amount of thermal energy at this time and why? Now, least thermal amount of energy, okay, is gained. It's what? Y. Bravo. Yes. Okay. And why? Because cold air still falls and is still inside it. So number 19, the answer is what? The answer is what? C. But freezer Y, okay, X-ray, it what? Not, it doesn't get least thermal energy. It gets a lot of thermal energy because the cold air, okay, falls from it, and cold air, warm air is replaced inside, right? Yes, exactly. You have to be careful, Muhammad. Yes, thank you. Good. So we know that cold air falls, okay, tamam, not warm air, and the freezer that gain least thermal energy is what? The one which is Y. So the answer is C. Question number what? Question number 20. This is about waves, third block in the IGCSE Cambridge syllabus. A wave of frequency 6,600 hertz travel at what? A distance of 1,320 meters in 4 seconds. What is the wavelength? Now we know that speed equal what? Frequency multiplied by wavelength. We know this. But this is the second step. I know that the wavelength equal the speed divided by what? The frequency. But I don't know how fast is the speed. So I need to find it out. So first step, I need to find the speed, which is distance divided by what? Divided by time. Okay? So the distance here, which is 1,320 divided by what? 4, and the answer will be how many meters by using calculator? Huh? Who has a calculator? It will be approximately 600 something, right? Who has a calculator? Sorry, 300 something. Let me check how much is the answer. So 1,320 divided by 4. The answer 330. The speed of sound in air. So here the answer it will be 330 divided by 6,600, and the answer it will be how much? The answer it will be 0.05 meters. So the answer is A. Good. Any question? We was talking about thermal physics here. Then we travel to what? To waves. Okay, you have to be careful about this information and these formulas. You have to know it. This formula I told you several times. Speed equal frequency multiplied by wavelength. They keep using it in the as a part of the question. Okay, this is question number 20. Question number 21. What they ask? The diagram shows a wave. As you can see, we have a wave and a half wave. Okay, so wave and a half. What are the amplitude and the wavelength of this wave? Now we know that the amplitude is this distance. This is the amplitude, the distance between the peak on or the crest to the equilibrium position. So the 6 meter is actually twice the amplitude because from the crest to the trough vertically. Okay, And this distance, the 4 centimeter, actually is what? It's half wavelength, wavelength divided by 2. Okay, but the distance between crust to the next crust, it's what is the wavelength. So the answer is the amplitude is 3 and the wavelength is 8. So the answer is B for question number what? 21. Okay. Next, question number 22. What do we have here? In question number 22, which statement is correct? The speed of light in a glass is equal to the speed of light in vacuum. No, of course not. Okay, multiply by the refractive index. Okay, actually, we know that refractive index equal C la V. So when we do cross multiplication, that means the speed of light in vacuum is equal to the speed of light in glass multiplied by the refractive index, not the opposite. Okay, so the multiplication is not correct. B, the incident angle of the ray and air glass, okay, of surface is the angle between the ray and the surface. Is this correct? Is the angle of incident between the ray and the surface, or the ray and the normal? We have to write with the normal, right? So also, what this is not correct. See, the sine of the critical angle at air of the surface is equal 1 over the refractive index. Now we know that Ni sine I is equal to what? Nr sine R. Okay, or for example, travel from the medium to the air. So this is the N for the medium, equal multiplied by sine the critical angle, equal N in the air, which is 1, multiplied by what? Sine 90. And we know that sine in 90 for critical angle, it will be 90, and sine in 90 is 1. So that means N is equal to 1 divided by what? Sine critical angle, or as they said, sine critical angle is equal to 1 over N. So far, okay, C is the correct answer. In part D, what do we have here? The angle of refraction for the light passing through air glass surface is proportional to the angle of incident, okay, at that surface. Now, there is a relationship, okay? There is a relationship between what? Between the angle of refraction and the angle of incident, okay? But actually, they are directly proportional, the sine and the sine, because we know that N equals sine I over what? Sine R. So sine I is directly proportional with sine R, not I directly proportional with R, or not I proportional with I. So the correct answer is what? Is C for question number 22. So this also not correct. The angle with the angle is not correct. Okay, the sine with the sine, yes, it's correct. Good. Okay. Question number 23. A narrow beam of light passes through a prism, okay, and is dispersed into the spectrum, okay? This is white light, it's not monochromatic. And I told you about Messi and Cristiano Ronaldo. So we said that Cristiano Ronaldo is playing with Manchester United, which is the red, while Messi, okay, Messi is what? Is playing with Barcelona or with Paris Saint-Germain. It's blue or violet, okay? So that means, okay, both have the same speed in air, both colors, but as they deviate, they refract, they go to a slower medium, they change their direction. Since Messi is a slower, it has more frequency. So the frequency for Messi is higher, and the wavelength is what? Shorter. It can deviate more, it can refract more than whom? Than Cristiano Ronaldo, which has longer steps. He's taller, okay, and has lower frequency, lower number of steps of his feet when he ran. So that means the red is the number 1. This is red, okay, and this is what? The violet, and the number 2 between them, it will be green or yellow or whatever. So number 1, it's red. Number 3, it's violet or blue, and that makes number 2 is what? The yellow or the green. So the answer is what? The answer is C. Okay, good. Number 1 is the red. Cristiano Ronaldo does not refract or dispersed or deviate its direction as messy, okay? As he slows down. Yes, we told you about that when we explained it in that time, when we talk about refraction and dispersion. You remember? Okay, Sarah, is it clear? Is it clear now? Okay, what about you, Muhammad? Is it clear? طيب, تمام. Okay, number 24. An intruder, okay, intruder alarm, intruder alarm system detect that a person is warmer than his surrounding, okay? Which type of electromagnetic wave does the sensor detect? Okay, which type of electromagnetic wave does the detector detect because he's warmer? Yes. Who can give me the answer? Because he's warmer. Exactly. It's infrared. Bravo. Shukran. Thank you. It's infrared. Any warm body release amount of radiation. Okay, that's because it's not burning. Okay, that's not visible light. It's below visible light. That's why we call it infrared. Okay, and I told you that's how animals see each other and see us. Okay, during the night. So number 24, the answer is what? Is A. Number 25. Sound travels through air, okay, as series of compressions and refractions. We are talking about sound, where, and air. Which statement correct compares, okay, the compression with refraction? Now we know the compression, the region where air molecules are close to each other, and the refraction where the air molecules are what? Far from each other, right? So that causes high or low what? Pressure. So there is high or low density of the air. So A. In compression, the wavelength is longer. No. In compression, there is no wavelength difference between compression and rarefaction. Okay. In compression, the density of the air molecules is greater. Yes, because the air molecules are closer than refraction. In the compression, the density of the air is lower. It's not correct. So the answer for 25, it's C. Yes, thank you, Shabab, Muhammad, and Maryam. Yes.